In a previous video, I was presenting the concept of doing handwritten digit classification using what I called a difference from mean classifier. So what we were doing there is we were taking all of the 0 handwritten digits in the data set and computing the average image, and likewise for the other digits. And so this is what that looked like for the handwritten digit 1. So feel free to look at the previous video for a little bit more detail there. What we concluded at the end of that was that the accuracy for that very simplistic technique was about 58%, with the curious exception of especially this handwritten digit 1 that scored an amazing 99.9% accuracy using such a simple technique. A follow-on to that, though, is this is the result if you simply use what you might call the absolute difference when you're comparing two images. So in this first example here, when we compare this average 0 to a particular handwritten 1, if we compute this difference image here and then just sum up all the pixel intensity values, that would be the absolute difference. But often in statistics, we want to use something a bit more sophisticated than that. For example, sum of squares. And so what you would do there is for each pixel intensity in this difference image, you would first square it before you then produce the full summation. And the effect that that has is that we don't pay as much attention to pixel intensities that are in the kind of grayer spectrum. We're kind of more suspicious of those things, and we might want to treat those as noise, and so we kind of suppress those differences. Meanwhile, we pay relatively more attention to the high intensity colors. So this bright white here and this bright white down here, that is has a kind of a stronger signal to noise ratio, and so we want to pay more attention to those differences. If we do that, you might wonder, what effect does that have on the accuracy? So again, our average before was 58%. When we apply that change, it is pretty significant. The overall accuracy jumps up to 81%. Interestingly, the accuracy of the one digit does fall from 99.9% to 96.3%. In the grand scheme of things, that's well worth the sacrifice and not that big of a deal. Although, if you're just purely looking at the accuracy, or rather the error here, you're multiplying the error of the one digit by a pretty big number to go from 0.1% to an error of 3.7%. So it's maybe 37 times more error there. But it's just an interesting little experiment to run to see just how much difference sum of squares can have versus a pure absolute difference.